In many modern mindfulness spaces, walking meditation is framed as a functional break, a period to stretch the legs between seated sessions. Locomotion provides a specific set of parameters that can be tuned to engage the nervous system directly. Across different Buddhist traditions, the simple mechanics of a human step are systematically adjusted to achieve varying mental states. Practitioners manipulate specific variables: the physical pace of the stride, the angle of ocular focus, the posture of the hands, and the primary cognitive anchor. Adjusting these variables drives the nervous system toward different outcomes, from precise analytical insight to deep meditative absorption. We can deconstruct the protocols of Theravada, Mahayana, and Vajrayana Buddhism by viewing them as distinct cognitive algorithms. Applying a generic label to walking meditation overlooks its capacity to interface with the brain's internal error detection hardware. To understand this interface, we have to look at the biology of a baseline step. Under normal conditions, human locomotion occurs without conscious awareness. Before the foot even moves, the motor cortex fires a command and creates a predictive template of what the step should feel like. This template is the efference copy. It routes into the episodic buffer of the working memory system, waiting for sensory feedback. As the foot strikes the ground, raw sensory data travels back up the leg. This reafferent signal meets the efference copy for a direct comparison. If the expected sensation matches the actual sensation, the nervous system clears the movement as routine. The action is processed automatically, allowing the default mode network to engage in mind-wandering. The locus coeruleus, the hub of the brain's norepinephrine system, functions as the primary center for arousal and error detection. Mindful walking disrupts the automatic baseline by forcing a high-resolution, deliberate comparison between expected and actual sensations, triggering this error detection system. This comparison flushes the system with noradrenaline. The spike in arousal maximizes selective attention and collapses the mind-wandering state. The Mahasi Sayadaw lineage of the Theravada tradition treats the walking path as a laboratory for microsensory observation. The physical inputs are strictly defined: hands clasped in front, gaze locked exactly 2 meters ahead, and the pace brought to an extremely slow crawl. The practitioner executes chronophotographic noting, applying continuous, rapid-fire mental labels to the movement. In this model, the step is dissected into 3 distinct segments. The practitioner isolates the exact moment of vertical detachment, noting it as lifting. Next, they isolates the trajectory of the foot moving through space, applying the label moving. Finally, they pinpoint the microsensory fluctuations of the sole making contact with the ground, noting it as placing. The Mogok Sayadaw method uses a similar pace, but directs the practitioner to observe the immediate dissolution of these contact sensations, aiming to sever the psychological link to craving. By tying explicit cognitive labels to these microfluctuations, the practitioner saturates the working memory system. This reveals the body not as a solid entity, but as a series of disconnected, fleeting sensations. A common view in meditative circles suggests that deep, unified absorption, or jhāna, requires absolute physical stillness. The forest traditions of Sri Lanka and Thailand challenge this by using walking paths to balance physical energy with mental concentration. The Pa Auk Sayadaw protocol demonstrates that profound meditative absorption can be maintained during active movement. The transition is a precise sequence. The practitioner enters the 4th level of jhāna while seated, then slowly stands, actively resisting the tendency of attention to flow out through the visual field. This map illustrates the mechanism of aggressive sensory-motor gating. Peripheral visual data and kinesthetic inputs from the lower legs are completely ignored. Spatial navigation is delegated entirely to implicit motor programs. The legs move automatically, while the conscious mind remains anchored to a single point at the upper lip. The central executive workspace remains fixated exclusively on the internal nimitta, or counterpart sign, while the body moves on autopilot. By leveraging the brain's sensory-motor gating mechanism, the mind sustains total absorption even while calculating the physics of locomotion. In the Mahayana tradition of Zen, movement is practiced as a direct physical expression of Buddha nature. The 2 primary Zen walking methods, known as kinhin, utilize contrasting physical parameters. The Soto school emphasizes extreme slowness. Hands are held at the sternum in the Shashu mudra, with the practitioner taking only 1/2 step per full cycle of breath. The Soto approach utilizes shikantaza, an objectless awareness that experiences the unified body in motion without the use of noting or mantras. The Rinzai school employs a brisk and highly dynamic march, often conducted in a tight, energetic single-file line. Rinzai uses this physical kinetic energy to focus the mind on the great doubt of a koan, demonstrating that velocity can function as an independent variable for concentration. The Vajrayana practices of Dzogchen and Mahamudra seek to dissolve the boundary between formal meditation and everyday activity. In Dzogchen, the physical parameters call for a natural pace with the eyes kept wide open, gazing softly toward the horizon. The cognitive protocol involves a suspension of mental effort, allowing thoughts and sensory stimuli to arise and fade without attachment. Tantric energetics reach an extreme in the practice of Longompa, or Tibetan trance running. The biomechanical protocol relies on rhythmic breath retention and an unbroken visual lock on a distant point. In the tantric model, the practitioner cognitively binds their mind, the rider, to the subtle internal winds, which function as the horse. This integration of breath, gaze, and internal energy allows for high-speed transit over vast distances, extending the traditional boundaries of human motor performance. The act of walking provides a continuous stream of high-fidelity biological data to the brain. Locomotion serves as a neutral carrier wave for whatever cognitive algorithm the practitioner chooses to execute. The outcomes cover a vast spectrum, from the microsensory noting of vipassanā to the sensory motor gating of jhāna and the open awareness of Dzogchen. Utilizing the walking path effectively requires looking past the idea of walking as a passive rest period. The path is a controlled environment for observing and manipulating the mechanics of your own attention. By matching a specific kinetic protocol to a phenomenological goal, walking ceases to be simple transit and becomes a precise instrument for awakening.